Hello and welcome to one and all present here. I, Amrita Varshini V, Assistant Professor, Department of Civil Engineering, VVCE, Mysuru, here today to speak about structural analysis topic under GATE Training 2023. Let us move on to the topic. As I said, structural analysis is the topic that we are here going to study today. And if you know strength of materials and engineering mechanics subjects very well, then this subject is very easy to understand. Nevertheless, we will try our best to go through few of the problems under structural analysis topic. So let us know what are the basics that we need to know under this topic. Today we are going to discuss about method of joints and method of sections problems. So the basics that we need to know about the trusses are, in the trusses, the load is applied only at the joints. So the load is not applied at the members, it is applied only at the joints. Members are connected at joints using frictionless pins, and hence all the joints are considered to be hinged support. Okay, all the load is applied at the joints and not at the members, because when the load is applied at the members, the trusses becomes frame. Hence, the load is applied only at the joints. The third point says the member forces are axial in nature. Yes, in trusses you will not see any bending moment and you will see only axial forces, and these forces can be compression as well as tension. It can be compressive force or a tensile force in the members. The last point is method of joints and method of sections. So these two are the methods that we follow in order to find the member forces. So if we want to find the member forces, we need to use either method of sections or method of joints. As you all know, method of joints is the method where you consider one of the joint in the truss where 2 to 3 members are connected to it, and each member forces need to be found using sigma fx equal to 0 or sigma fy equal to 0. So these are the two functions or the equations that we make use in the method of joints to find out the internal forces. Now, briefing about the method of sections, the entire truss, let us say this is one truss, and we want to find out the member forces in this particular member and this member and this member. Then we are going to divide this section into two parts. This truss, this is one part and this is another part. So this part of the truss is considered to find the member forces. Now going to the first question, let us move on. For the truss shown in the figure, the magnitude of the force in kilonewton in the member SR is dash. Now this question was asked in 2015 in GATE, and look at this truss. This is a simple truss and they are asking you to find out the member force in the member SR. So you can see there is one load which is acting at the joint S, that is 30 kilonewton force, and there are many members, and the supports are hinged support at P and roller support at Q. They have given options of 10, 14.14, 20 and 28.28. So as you can see, the option A and C are 1:2, as well as B and D are 1:2. So that means they are giving you a hint that you will get any one of the options between either A or C or B or D. Now coming to this particular question, you can make use of either method of joints or method of sections. Let us say if we make use of method of joints, you can, if you want to make use of method of joints, first you need to find the support reactions that might be at P as well as at Q. So at P you will have two reactions, that is one is horizontal and other is vertical reaction. Now since there is no horizontal force on the truss member, this force will be 0. So you are left out with only vertical force. Let me call it as reaction at P, that is RP. Similarly, at Q, as you can see, this is a roller support. So you will have only one vertical support, that is RQ. Let us call it as RQ, that is reaction at Q. Since SR is very close to joint Q, let us start solving the joint Q, so that when we solve the joint Q, we will get the unknown, that is force in RQ. Once we know the force in RQ, if you move on to the next joint, that is R, you can solve force in member SR. So in order to find force in RQ first, we need to know reaction R, that at Q. Why? Because there are three unknowns in joint Q. Since using method of joints has only two equations, that is sigma fx equal to 0 and sigma fy equal to 0. We have two equations and hence only two unknowns can be solved, but at Q we have three unknowns. Hence, in order to find out one of the unknown forces, what we need to do is we need to find out the support reactions. Now first, how to find out the support reactions? We can make use of equilibrium equations. Let us find out sigma m at P. What happens if we find out sigma m at P? Sigma m at P, we know that it is equal to 0. When we equate the moment at P equal to 0, we have one load that is at S and we have one reaction at Q. Considering these two in this particular equation, we can find out what is RQ, that is reaction at Q. So let us find out 0 is nothing but moment at P, which will be equal to, now you can see at S we have one downward force of 30 kilonewton magnitude and it is acting in clockwise direction. So clockwise means, let us consider the sign convention as positive. Hence it will be 30 into what is the perpendicular distance? It is 2. So it will be plus 30 into 2. Okay, so we have considered one load and now we are left out with the unknown reaction, that is reaction at Q. Now reaction Q is making a anti-clockwise force around P. Hence, it will be negative minus RQ is the unknown magnitude that we need to find out, multiplied by what is the distance between the point Q P where you are taking the moment and the point Q where the reaction force is there. It is 1 plus 1 plus 1, that is 3. So if we solve this particular equation, what you'll get? RQ. So if you solve this equation, you will get RQ as 30 into 2 is 60. 60 divided by 3 is 20 kilonewton. Okay. So now we found out that RQ is 20 kilonewton. Any doubts here? So now that we found out what is RQ, we can find out what is RP. Is it easy to find out RP? Yes, we also have this we found out using sigma m at Q equal to 0. sigma m at P equal to 0. Yeah. So the second equation is sigma vertical forces equal to 0. We know that the let us consider all the upward forces as positive and downward forces as negative. So Rp, reaction at P, is upward force, so plus, minus 30 because downward force, and plus Rq because it is again upward force. If we equate this to 0, we can get Rp, which is simply 10 kilo Newton. Clear? So we found out this to be 10 and this to be 20, right? Now that we know that at Q we have 20 that is coming towards the joint, yes or no? The reaction is towards the joint. So now, since we have one vertical member passing through the joint Q, we can say that in member RQ, in order to counteract this compressive force, why is it a compressive force? The force 20 kilonewton is coming towards the joint. So whatever the force that is coming towards the joint is called as a compressive force. Whatever the force that is going away from the joint, it is called as a tensile force. So now, since it is coming towards the joint, even in the member RQ, the forces should be compressive in nature only in order to make this joint stay in equilibrium. So since this is compressive force, this also needs to be a compressive force. And now coming to the magnitude, we are clear with the direction now. Now coming to the magnitude, the same magnitude is transferred to the vertical force as there is no inclined forces attached to this particular joint. Since there is no inclined forces, the complete 20 kilonewton force is transferred through the member RQ. So this will be again 20. Clear now how this became 20? If you are still having doubts with this, you can take joint Q as the joint and write down the members that is passing through the joint. Clear? So this is our point Q. So this we know it is 20. So if you want to find out the RQ in another method, you can follow method of joints. If you adopt method of joints for this particular joint, you can easily get the same answer. Since you are doing this for the gate purpose, you need to be quick enough to judge whether the same force will be transferred to the vertical member, or you can simply follow this method which will be tedious in nature. So instead of consuming a lot of time in solving the joint Q, we can clearly, through vision, we can say that the complete 20 kilonewton force that is coming to the joint Q through the support is transferred to RQ member. Now that we know RQ, we can find out what is SR. So this is what we are supposed to find. Yes or no? In order to find SR, we can take joint R. So this is our R and this is our member SR. This is RQ and this is RT. So this we know that it is compressive in nature, which is 20. Yes or no? So now since this is R, this is 20. We don't know what is this angle. Do we know what this angle is? No. So in order to find out this angle, we can make use of triangle rule, tan inverse of opposite by adjacent. So opposite is 1, adjacent is 1. Since it is a square section, this will be 45 degrees. So we know that this angle is 45 degrees. Clear? So now This is compressive. Let us assume this also to be compressive in nature, and let this be tensile in nature, just for assumption's sake. If you get answer in negative, that means whatever the direction that you have assumed is wrong, you need to reverse the direction. If you have assumed it to be compression, and if you get negative along with the magnitude, that means it is not compression, it is tension in tensile in nature. So if we adopt method of joints for this particular joint, what happens? We can take sigma f x equal to 0 as the first equation, or the only equation that we need, because SR is purely horizontal in nature. So if we adopt only sigma fx equal to 0 equation, we can clearly find out forces in SR. So now we have uh, F SR, that is force SR, which is purely horizontal in nature, and it is in right side direction, hence we consider it to be a positive force. Now if we resolve the force, let this be force RT, because it is the force coming in RT, and this is our force SR. Okay, so if we want to find out force RT, this is the force RT. So we can resolve it into two parts. So in the horizontal direction and in vertical direction, since the angle is made with the horizontal force, this will get cos component, cos 45, and this will get sine component, sine 45, along with force magnitude, that is RT. Yes, RT. So this is just the resolving the force RT that you have learned in an engineering mechanics. So you have resolved this force. Again, x component is this one, F RT cos 45. So along with this force, another force is FRT cos 45, that is coming on this particular joint. So but this force is towards left side, hence it is negative, minus F RT cos 45. Is there any other horizontal force acting at this particular point? One is SR, one is horizontal component of the force RT. This is purely vertical, hence this will not contribute to the x direction. So that is all. So this will be equated to 0. We already know what is RT. So F SR is equal to, if we take it to the right hand side, FRT, we know what is FRT. FRT is 20. So 20 cos 45. Clear? So what is 20 cos 45? What is 20 cos 45? It is 14.14. Clear? Let us move on to the next question. Second one. So for the truss shown in figure, the magnitude of the force in member PR, where is PR? PR is the hypotenuse side of this particular triangle, and the support reaction at R are respectively. We need to find the support reaction at R. We need to find the support reaction at R. That is one thing. And second one is magnitude of the force in member PR. In member PR, what is the magnitude of the force? So these are the two things that we need to find. If we look into this problem clearly, can we make use of method of joints or method of sections? It is better for us to make use of method of joins here, because first is they are asking you to find R. So if you need to find R, you have only one force and you have only three members, and hence instead of dividing the entire section truss into two parts, you can directly make use of method of joins. And one more hint given in the problem is through the options. Always in this type of questions, you look into the answers and then try to solve the problem. As you can see clearly, first is the loads of member PR that they have given, out of which option B and option C has the same value. Whereas coming to the support reaction R, you have two values, one is 50 and one is 100, which is repeated. Now, when you look into option B and option C, what you can clearly say is, since maximum options have the same value for the PR as 70.71, you can mildly guess that 70.71 is your right answer. This might not be true for all the cases, but it will hold good for most of the cases. Now we can blindly eliminate A and D. If you don't have much time to solve, you can directly go on solving for the R, because you have two options for R, that is 100 and 50. So if you have very less time and you still need to answer one or two questions, what you can do is you can simply eliminate A and D, because majority of the option for PR member has 70.71, and I definitely don't suggest this when you have lots of time. But if you have very less amount of time to solve more number of problems, I would suggest you to solve according to this. But this will not work all the time. Anyway, now moving on. So first let us find out the reaction R, because as I said already, we have two options for R, and we have three options for PR. So first let us solve for R. So in order to solve for R, what you can do, at R you have what kind of support? It is a roller support. And at Q you have a hinged support. And at P you have one inclined force, that is 100 kilonewton at an angle of 60 degree to the horizontal, which is being applied. Now this is 4 meter and this is also actually 4 meter. How you can say this is 4 meter? Because you have an angle of 45 degree. Okay. If you solve this using tan theta, you can get easily the PQ value, that is 4 meter only. So now let us start. So in order to find reaction at R, this is easy. Let us call it as FR. That is nothing but reaction at R. Yes or no? So now here you have two forces, vertical reaction at Q, vertical reaction at Q, and horizontal reaction at Q. So these are the three unknowns in this particular member. Anyway, if we take moment at Q, what will be the moment due to the force HQ? The moment due to the force HQ will be 0, because the HQ is passing through the joint Q, right? So there is no perpendicular distance between the force HQ as well as Q, as the HQ is passing through the joint Q. Now coming to VQ is also the force that is passing through Q, and hence there is no perpendicular distance between the force VQ and the point Q. That is the reason why if we take moment at Q equal to 0, we can easily eliminate two unknown forces, that is HQ and VQ, and there will be a moment due to force Fr because there is a perpendicular distance between the point Q and the point of application of Fr, that is R. So let us take the moment at Q so that we can easily find out Fr, that is the force at R, which is the thing that we need to find as per the question. So let us find out sigma m at Q equal to 0. In order for this to apply, we need to resolve this force into two categories. So to resolve, you can always, the best method, if you find what is the direction that we need to put, if you still have confusion in that particular aspect, what you can do is, you can simply go to the back end of the arrow. The arrow is here. Go to the back end of the arrow, draw a plus mark, and see where the arrow is going. The arrow is in between these two parts. So that clearly indicates that the resolved forces will have these two directions. So that is one of the easiest way to find out whether you are putting the direction of the resolved forces in a proper way or not. So you should go to the back end of the arrow, draw a plus mark and see where the arrow is lying, and just simply take the two directions of the x and y axis where the resolved forces will go. Now that we know the direction, this is one direction and this is another direction. Yes or no? So now it will be acting here. This will be 100 into, now look at this, the angle 60 degree is made with respect to horizontal axis. Yes or no? Now again, some people will have confusion in taking where to take cos theta and where to take sin theta. If you still have confusion in resolving that, whenever an angle is made with respect to the inclined angle, and if the angle is made with respect to the horizontal angle, then the cos component will go to the horizontal angle. If the angle is made with respect to the vertical axis, then the cos component will go to the vertical axis. You just need to look into the axis that the angle is made with and simply write cos component of that particular angle to that axis. So same 60 degree is made with respect to x axis. 100 cos 60 will be your x axis resolved force, and similarly y axis becomes 100 sine 60. I hope this is clear now how 100 cos 60 and 100 sine 60 came. So this will be applied here. This is your 100 sine 60. This will be your 100 cos 60. Clear? Okay. So now here these two forces are resolved. Now we need to apply sigma m q equal to 0. So let us apply sigma m q equal to 0. As we said before, only this force will come into picture as the unknown force, and the force that are coming onto the q will be nullified because there is no perpendicular distance. So let us go one by one. We are taking moment at q. Keep your left finger on q and see, look at this force 100 sine 60. The line of action of 100 sine 60 is passing through q. Yes or no? 100 sine 60 is passing through q. Now since 100 sine 60 is passing through q, the perpendicular distance between these 100 sine 60 and q will be 0 again. So this force will be nullified because there is no perpendicular distance between 100 sine 60 and q, right? They both overlap on each other. Now look at this force 100 cos 60. 100 cos 60 and Q. Keep your left finger on Q and look at 100 cos 60. It is making a clockwise movement. Yes or no? So now since it is making a clockwise movement, 100 cos 60 will be positive. Yes, that is the magnitude of the force. Now what is the perpendicular distance between 100 cos 60 and Q? What is this distance? It is nothing but 4 meter, right? Now how did it become 4? I already told you, since it is 45 degree, tan inverse of uh, tan inverse, if you apply, you will get PQ as 4. We already know what is tan theta. Tan theta is opposite by adjacent. So opposite is nothing but adjacent multiplied by tan 45. So you will get the distance as 4 meter. So this is 4 meter. So multiplied by 4, you are done with this particular force. Now you are left with FR, that is force at R. Now look at the force R and keep your left finger at Q. You can see FR is making an anti-clockwise rotation. That means negative sign will be considered. So minus FR multiplied by the distance is, again, the perpendicular distance between the force is this distance. What is this distance? 4 meter. So multiplied by 4, which will be equal to 0. Again, so now if you solve this particular reaction, you will get FR will be equal to 50 kilonewton. Got it? You got the answer in very first step itself just by solving only one equation, that is sigma mq equal to 0. Now go to the options. You can see 50 kilonewton is available here as well as here. If you have very less time, you simply mark this as the answer, because you have two same answers for the PR member. If you still have time, if you can recheck it whether the answer is correct or not. Now that you have got 50 kilonewton as the answer, this is eliminated and this is also eliminated. Yes or no? So now we are left with A and C. So let us see if it is A or C. So in order to check whether the answer is A or C, we need to find PR force. Now how to find PR force? How to find PR force? You can just simply use method of joints. Method of joints. At which point? Which point do you think is easier for you to apply method of joints to check, to get the correct answer? You can apply at P, you can apply at R to find out member force PR, right? So if you apply at P, you will have resolved forces of 1 and 2, 2 forces, 3 and 4. So you need to consider 4 different forces in one particular equation. But if you look at the joint R, you have only FR, which is known, and 2 unknowns. And since you have only 2 unknowns, both the unknowns can be found using 2 equations, that is sigma fx equal to 0 and sigma fy equal to 0. So since this seems a little bit easier, we'll go for joint R. We'll draw the same joint. This is the joint R that we have. What we got? We got it as 50 kilonewton. This is our joint R, and this is 45 degrees. This is our joint R, and this is 45 degrees. We have to find out what is FP R. We are least bothered about what this is, F, R, Q, right? Because in question we only need FPR and not FRQ. So we can make use of any one of the formula, be it sigma Fx equal to 0 or sigma Fy equal to 0. So these are the two equations that we have to find out force in PR. Now look at the first equation, sigma Fx equal to 0. If we apply this equation, we still have to find out FRQ, which is not needed for us in this particular question. Hence, we'll directly go for sigma Fy equal to 0, as this is a purely horizontal force. This force can be avoided. So if we take sigma Fy equal to 0, so what are the forces that are in vertical nature? One is purely vertical force, that is 50, which is in upward direction. Hence, it will be plus 50. Now, we have considered here it to be a tensile force. What? PR direction is tensile in nature. Yes or no? The arrow is moving away from the joint. So let us assume it to be tensile force as of now. Since this is tensile and inclined force, this inclined force needs to be resolved. Let us resolve it into x and y components. So if we resolve it into x and y components, this is our force FPR. If we resolve it into x and y components, so this is 45 degree. We already said that the angle is made with horizontal axis, hence cos component goes to, yes, horizontal axis. So this is our FPR, cos 45. So this will be the direction of the resolved forces. Since this is cos component, this will be sine 45. What sine 45? Force FPR into sine 45. Now, since we are concerned with only the y component is positive. So, plus FPR sine 45. Okay. Is there any other force here which is vertical in nature? No. So this will be equated to 0. So now, if we solve this particular equation, we get FPR equal to 70.71 kilo Newton. Now go back to this particular thing. So 70.71, yes or no? This is what I said. If you have very less amount of time, you can simply mark this particular answer. In this particular case, this holds good. So we have got the option as 70.71 and 50 kilo Newton. Clear with this? Okay. Let us move on to next question. For the truss shown in the figure, the forces F1 and F2 are 9 kilonewton and 3 kilonewton respectively. So this is 9, this is 3. The forces in the member QS is to be found. So where is the member QS? QS is here. Okay. And we need to find the force in member QS. Now look at the option. You can only get two answers, either 11.25 or 13.5. So these are the only two values. But if you make any mistake in writing or noting down the direction of the magnitude, you might end up with the wrong answer. So this is a tricky question. Nevertheless, it is very easy and simply you can answer it with just one step. You have to solve using only one particular step. Now, if you make use of method of joints, you have to start by solving all the support reactions first, and then you need to solve each and every joint in order to end up at joint S or joint Q to find member QS, which will be very tedious, and it is not suitable for gate examination. So for this type of competitive exams, what you can simply do is you need to think about how you can reduce the time in solving this particular problem. So what we can do is, instead of going for method of joints like in earlier cases, here we can easily adopt method of section. As we have already discussed, method of sections means you are cutting the section into two different parts and you are considering only one section for your calculation purpose. So now, since we need to find out the member QS, we will cut this section, the truss, into two different parts. If you consider the left side of the part, you will be left with only force F1 and you have S. If you solve only the left portion, you can easily find out what is the force in member QS. So first, let us assume cut the truss into two parts. Now that this force is exposed, let us call this force as F SQ or QS, and let us call this as F ST. Okay, so these are the two forces which are unknown to us, and this is an angle that we need to find because this is an inclined force. In order to find the angle here, we still have a triangle. We can draw a perpendicular here, bisector. This will be 90 degrees, and since this is 3 meter, what will be the distance here? This distance you can clearly see here. If we draw a perpendicular bisector here, this distance will be 1.5 meter, because 3 divided by 2 is 1.5 meter. So now you have 1.5 meter here and 2 meter as the height. Can you find out what is the angle? How do you find out the angle? You can simply make use of tan theta. What is tan theta? Opposite by adjacent. That is nothing but 2 divided by 1.5. Tan of 2 divided by 1.5, you will get 53.1 degree. This will be your angle, 53.1 degree. Okay. So since this is the angle that you have got, let us take the forces as mentioned, FQS, and this is FST. All we need to find is FQS and not FST. So what we'll do is, we will resolve this inclined force first. We have cut this section here. So at P, we have F1. Yes. So this is our inclined force FQS. If we resolve it into two parts, we will get FQS cos theta or sin theta again here. Yes, it is cos theta because angle is with respect to horizontal axis. Cos 53.1. Again, if we look at the y-axis resolved force, it will be FQS sin 53. It is 53.1. So since you have one force, we need to find FQS. Since we don't have any horizontal forces here, we cannot make use of the horizontal resolved force. So if we apply sigma V equal to 0 to this particular portion, can we easily find out the force FQS? Yes, since we have two vertical forces, which is F1, which is acting downwards, and FQS is acting upwards. FQS sine 53.1 degrees. So by applying sigma V equal to 0 minus F1, that is nothing but 9 degrees, so 9 kilonewtons, yes, plus FQS sine 53.1 will be equal to 0. As in the left side portion, we don't have any other vertical forces. F1 we already know, that is minus 9 kilonewton plus FQS sine 53.1 will be equal to 0. Using this equation, we can easily find out what is FQS, and FQS came out to be 11.25 positive. Positive means whatever the direction that we have assumed is correct, and the direction that we have assumed is tensile in nature. Yes or no? Tensile in nature. If you had assumed it to be a compressive force, you would have got minus 11.25, which is nothing but the assumed direction is wrong, and it should have been tensile. Since we have assumed tensile, it has come out to be the true. So the option for this particular answer is 11.25 tensile. So let us all stop here for today's session, and we'll meet you in the upcoming session. Thank you.